Hello and welcome to the series of short staple spinning. I am S.G. Kulkarni, retired professor from DKT's Textile and Engineering Institute. Now, we have seen in the earlier four presentations what I have uploaded that in case of certain aspects, like say for example in case of blow room we had seen that certain requirements were there, that what I call them as preconditions. Another very short point before we start this discussion, that in case of blow room when I started the presentation, I stated that the bale, Indian bale is of 170 grams. Just it was a oversight. Actually, it should be 170 kilograms. Though I have added the caption there in the description box, I don't know whether some people have noted down that one or not. Okay. So what I was discussing was there are certain preconditions for certain operations to take place. For example, in case of blow room, if the cleaning has to take place, first opening has to take place. And this is to happen, roller is there, roller is required, assisting element or grid bar is required, a feeding system is required. These things, when they go in the next level, for example, in case of carding, when we go to the third department in the spinning, that is the carding, in case of this one, earlier in the conventional days, they used to use flexible wires on cylinder, doffer, etc. etc. Of course, uh, we will also get familiarized with the this what doffer is, what cylinder is, etc. in due course of time. But to start with, these rollers now are to be covered, wire covered. There are certain specifications of them. It is impossible to cover all these details in this outline type of a presentation. So I will go only essential technical things in entire this series, as I have done in case of the blow room also. So roller covering is there, roller distancing is very important. How they are set apart means settings are required, and then their speeds are required, and not only speeds but their direction of rotation is very important. Then and then a designated operation that particular roller will do, otherwise it is impossible for that roller to do that operation. And since this is the technology, we are using the machinery for getting our work done, technical work done. Now when we have seen in case of blow room, we have seen that opened flocks are delivered from the blow room, and trash, what I have discussed there cleaning efficiency wise, that trash also has been got rid of. Now still trash is present, certain kind of trash is still present in these flocks. So that is required to be, say, removed here. Certain area, certain zone, what we will call henceforth the zones in different systems. In carding also there are various zones. So in that zone, a certain kind of operation will be done. Eradication, elimination of the trash will be done at certain zone, that is the liquoring zone, for example. And then carding will take place. Means in the flock, how many number of fibers are present, that depends upon the flock size. That flock size is getting further reduced. And what happens in case of carding is the operation of segregation of fibers. Some of the time, some people call it as the separation, fiber separation. But fiber separation is not the appropriate technical word to use. Why? Because if fibers are totally separated, their identity is that is lost, they are independent of one another, then problem will start. And because of certain spinning values, what we have seen in the earlier segment also, that because of that coherence or adhesion property of the cotton fiber especially, these all operations are possible. This is a very key point. We are required to remember this thing, that cotton fiber has cohesiveness, and that makes all these operations very simple, and they can happen. So lot of fibers in the flocks, now they are getting reduced, and they are in this segregated, they are together but they are segregated, identities are separated to some extent. So this is what happens in case of carding department. So let's go further. Thousands of fibers, lakhs of fibers you can say, are now going to get converted to thousands, 10,000, 20,000, or something like that, with a segregated identity. So, because this operation is done in case of the carding department or carding machine, it it gives a foundation for the further processes. It acts as a foundation. It acts as a foundation. So that's why they say that the card is heart of spinning. Card is heart of spinning because if carding does its job properly of segregation and delivering the mass of a particular order in the form of a sliver. Now, of course, many people must be knowing this thing, that the card's product is a sliver which comprises around say 10,000, 20,000 fibers in the cross section. Now that depends, of course, what hank we are producing. In the traditional English count system, it is hank or count of the sliver. In direct system, the linear density is talked of. That is gram per tex or kilotex, something like this. So these are some the terms which are used there to denote the product's identity. So well carded is half done. Card is heart of spinning, and well carded is half done or half spun. Well carded is half spun because if proper opening segregation of fibers has occurred here while the fibers are delivered from this machine in this sliver form, further the succeeding, in case of the carded route, in the flowcharts we have seen this thing. Carded route is there, combed route is there, and unconventional spinning route is there. So three basic fundamental routes are there to spun the cotton yarn. So well carded is half spun. Now this denotes actually the significance of carding. So we are going to see in the succeeding slides what actually carding has to do, what carding does. There is no single process at any stage to form such a important condition like carding. So this is F. Liefeld. I earlier uttered his name during the Blue Room. So he says this thing, that it is very important to point out this thing, that do the carding properly is very important aspect. The card has considerable effect on yarn quality. Now it is arising of a complex events and processes itself on the pressure to adopt extremely high production rate, economic grounds, etc., etc. In simple words, here what flocks are going to be fed in the given, under the given condition, under the circumstances, card has to perform. And card, another very important point here is, card is a good leveler, so to say. Good leveler in the sense, though the fed material might have had variations, weight variation, though we adopt certain regularizing mechanisms, regulating motions there in the preceding stage, but still this is a uh, this is a from a fiber to yarn process. So number of constituting elements are there. Fiber is the constituting element, and from such a small constituting element, you want to design a product. This design plays a very vital role actually. So in this process of manufacturing in the spinning department, it is associated with variability. At certain stages, though we take some precautionary measures, some machineries are employed, but still there are some, say, variations, they are imbibed, they are still remaining in the incoming product. So we are required to, the card is required to regularize them as far as possible. So this slide depicts about some historical things, that earlier what production rate was there, and even the rate has gone up in the today's situation. In the last slide, we are going to see this thing, that at present what are the conditions. Production rate increase definitely is one striking feature that has happened in the spinning department. At each stage, production rates have gone up definitely, but because of the technical excellence, what, say, refinements we have made over the years, what has started in the initial stage as a carding machine, now it has undergone a very tremendous drastic change. Though apparently this process might be looking the same, but minute and minute, very minute, fine, say, tunings are there on today's machines, and that's why we are able to increase the production rate. At the same time, of course, one has to mention that there are a lot of improvements in the raw material that is being obtained, and mainly our focus, as I am say time and again I am saying, that our focus in these presentations, series of presentations, is basically on cotton. But once we understand the process here in the context of cotton, I hope it can be easy for it can be easy to understand when fibers are different. And again, more or less same things are adopted in manufacturing of blended yarns or viscose material also. That is again a different point. So in today's situation also, the importance of carding cannot be dispensed of. In fact, it has gone up. I think I have mentioned about the NEP content chart. NEP generation, what was there 100% in the conventional blue room line, it has come up to, in the modern blue room line, up to say 80%, 70-80%. And NEP elimination, NEP reduction has almost taken place 70-80% in case of carding department. So overall, now in today's situation, the card room will look like this one. This is an overview of modern card. We have seen in case of blue room also that we are having the chute feed system. So that way the cards in entire department, whatever, say, hang they are working upon, what product mix is there in the spinning department, accordingly that work will be got done from same installed cards. There might be some cards which are allocated for some mixing, and there might be some cards which are allocated for some other mixing. That depends, of course, that is a slightly managerial aspect. So but still, that, say, that one exists in the spinning plant. Now, objects of carding. This is from where now we are going towards the basics of carding. Opening of the flux, as I have mentioned, opening of the flux to the individual segregated stage or segregated position. Elimination of impurities. Now, elimination of impurities, that will take place as Earlier also I have discussed in the blue room line. Now the trash is also categorized. 500 microns and above, it is the trash. 50 to 500 microns, it is the dust. Now 15 to 50 is fine dust, and below 15 micron, it is the micro dust. So that way, a larger size of the trash will be removed in a typical liquorine zone, and then in the succeeding process, the rest of the trash impurities rather, that will be taken care of. Elimination of dust, disentanglement of nets. It is disentanglement of the nets, elimination of the short fibers, especially a certain degree of short fibers can get eliminated in the flat zone in between the cylinder and flats. So that is also a very important point. Fiber blending, this is definitely a very important aspect, because now we are going to see, of course, when the fiber flock comes from liquorine onto the cylinder and it undergoes the carding process in between the cylinder and flats, here the blending takes place. Fiber orientation to some extent, as the modern attachments are there on the modern cards, the instead of the back plate and front plate, they have gone for stationary flats, etc., etc. Because of that, the fiber orientation is enhanced, and then sliver formation. Of course, sliver is formed, as I have already discussed. Now, opening the flocks. Here, I have mentioned in this slide also that Blue Room has already done this job. But in case of the carding, we are required to further go for the opening of the flocks. And here, as I have mentioned earlier also, that at certain zones, certain operations are done. Certain operations are done. So in the feeding zone, now here in case of this slide, you can see here, yeah, here you can see the chute feed system is there. Now, I have to mention here, there are various changes they have taken place. Now, in the conventional card, only we were having a lap feed system. Blue Room was producing a lap, and these laps were carried to the carding department, and they were kept at the back side of the card. Then lap roller, etc., that used to unwind the lap, and then that was fed to the first zone. On the feed dish plate, the lap was fed to the feed zone of the carding. So on carding, now this is the point here. There are different zones, different preconditions I have mentioned: wire covered rollers, their speeds, their direction of rotation, etc., etc. Now zones. Here mainly three zones are there. One is feed zone, second one is carding zone. Feed zone is somewhat here. Feed zone is up to here. You can see in this slide here. And then carding zone is this zone up to this point. And then doffer is there. And then this is the delivery zone. And this is coiling, of course. So end product is stored in a can here. So this can be said to be, say, added one more zone, you can say. But mainly, basically, operation wise, three zones are there. Yes, what we can see here is opening effect is directly proportional to the number of wire points on a given surface and two interacting surfaces. This is very important point here. PPSI, points per square inch, as far as a particular element is concerned, like cylinder for example, and effectiveness of that operation depends upon the feed roller and the taking roller. their wire number of wire points interacting at a given instance. Now, as production rate has gone up, this interaction residence time available for the fiber treatment is diminishing, it is reducing. Residence time has gone down because production rate has increased. So, this point again becomes very, say, important, very crucial when we consider number of wire points per fiber. Now, elimination of the impurities. Now, as I have say mentioned, different manufacturers are using different techniques. Now, I have taken one typical technique here. For example, retail people in the modern car now they have their latest C81, and Tuzler people they are having their TC30i, something like that. They are having their own specialities. Now, the concept here is the unidirectional feed. Unidirectional feed means in the say conventional days, when the fiber flocks were fed to the liquorin, which is covered with wire points, 300 400 points per square inch normally. That depends, of course. I am just stating a figure here that can be varied also. And a typical construction of the wire point also is required on liquorin because it is doing a gripping and beating job. The material is gripped in between the feed roller and the feed plate, and then it is beaten up by the liquorin. But important point here is, one can see this is the unidirectional feed. Now in this one, the direction, this liquorin is rotating in this direction, say from the front to the back, in this direction, and in the same direction the feed roller is putting the material forward, giving the material in. So that is unidirectionally it is fed. So harshness of the action gets drastically reduced, and we can get a certain in the range of 80 to 95% overall cleaning that can be obtained here in this zone itself. In this zone itself it can happen. And card taken together, now we are required to take blow room and card combined cleaning efficiency. It can go up to 90 to 99%. So card sliver produced will have very rarely 0.05 to 0.3% foreign matter, any extraneous matter present in that. So this is high level of cleaning that is obtained. And as I have highlighted here, that the unidirectional feed is doing its excellent job, that it does not hamper, it does not physically damage as it is claimed by the rulers. Now many say variations have been tried. Multiple liquorins are tried on some other system. Multiple delivery rulers are tried after the Doffer by Marzoli, Crossroll, Varga, etc. etc. So one transfer roller, crushed roller, redirectional rollers, etc. on the delivery side, I am talking after the Doffer. So there are various changes. And again, one more very important thing is, a certain time was there around 1990s or something like that. At that time, tandem cards were used, and this transfer system actually first evolved, we can say, in between the two cards. After the first card, there was another card, and it was said to be a replacement to the combing. Of course, it doesn't do that job that much efficiently as the comber does, but it was claimed at that time. So cleaning takes place in this zone, in the takerin zone or liquorin zone of that order. So it is gripping and beating that occurs in case of this particular place. So this is the feeding zone. So we are separating such particles also in the blowroom, as we have seen that large portion of particles they are eliminated in the carding also. The foreign metals, small metal parts. Otherwise, what will happen is there will be a chance of fire here. Especially, cards are prone, susceptible to have fire. So, their elimination of this small, very fine metal parts, etc., that becomes very crucial as far as carding is concerned, along with the dust. Disentangling the naps. Now we can see here nap elimination also can take place, specially this does not occur in the liquorin zone. In liquorin zone, another very important point is we can take motes, waste as named as motes. The fiber husk which is carrying, I mean the seed husk carrying some fibers along with, so that is called as a mote, and that is a very damaging thing as far as further processing is concerned. So that is taken in the liquorin zone. Now naps are either disentangled or they are eliminated. Seed coat fragment, what I was just now saying, this is the seed coat fragment, and that is dropping there in the liquorin droppings. What waste we are getting below the liquorin, that is called as a liquorin dropping. What waste we take around the flats, that is flat strip waste. And what waste we take under the cylinder in the form of the suction, that is cylinder fly, doffer fly, something like that. So these are typical names which are given to these wastes which are taken at various places. So nap, which is the hindrance in proper spinning, it is either it is disentangled because of the action that takes place between cylinder and flats, or it is been eliminated. Dead fibers or immature fibers, etc., such which are causing the troubles, they are eliminated in the flat strip. Now next comes is what is the main heart of the carding. Carding is heart of spinning, and heart of carding is this zone, that is the carding zone. So here now various things have conventionally tried. Say cylinder normally that has kept some size also. 50-inch size cylinder has kept. Later people have increased up to 60-inch the cylinder size. Size 60 or 50-inch, points per square inch around 700-800 ppsi, 1000 even in certain cases 1000 ppsi points per square inch, and adjoined to that or in conjunction, in tandem with the cylinder, either a semi flexible wire, or in the conventional days it was a flexible wire carrying flats. Now this is a flat chain, actually chain of flats. In the conventional days 140 or something like that, 144, etc., these were the number of flats. Now it has come to 116, 114. But out of this 114, 116, etc., etc., hardly at a given time 30 to 40 flats are working flats. Working flats in the sense which are in the close vicinity of the cylinder, and once the flat, a given flat enters, for example this is the first flat which is entering at the top of the cylinder, and then when it leaves almost near the doffing arc here, by that time that flat has become full. So suppose there are some 35 working flats out of 114, 115. So what will happen is, this flat, once it comes here, already it has interacted with the rotating cylinder wire points, and carding has occurred here. As we can see, cylinder's direction of movement is in this, from back to the front. It rotates in the back to front direction, and flat usually they are traversing. It is a traversing of the flats on the bend, a rigid bend and flexible bend. It's a track, for example, on which the flats are traversing with a certain traverse speed as compared to the cylinder rotational linear speed rather, pi dn, diameter and rpm of the cylinder. So it becomes the linear speed, and this linear speed. So with the highest linear speed, against that a very slow linear speed of flats, there is a chance for wire points to interact, point against point. Cylinder point is interacted by a flat wire point. The tip of the flat wire, and tip of the cylinder wire, they will interact with a certain speed difference, as I have already stated, with the direction of their traverse and the vicinity and number of wire points. This makes the carding possible. So these are the preconditions which are required to met. Now Ritter people have worked with artificial intelligence in today's situation, and close set, they are using their own terminology, and this distance is continuously monitored on their system. And of course, IGS classic and IGS top. IGS classic, cylinder grinding, continuous grinding for the cylinder wires, so that they remain intact for the operation to take place, proper operation to take place. And IGS top is for the flats. When wire points are having their proper condition, their surface, interacting surface is correct. Normally it is square, the cross section. If it is that, then the carding will take place. If slight, say it has blunt, rounded edges, or it has gone blunt, then the carding may not do its job properly. So the carding to take place at whatever given the space, the sharp clothing, speed, etc., and speed of taker in or liquor in, speed of doffer, and the throughput on the production rate. But important point here is the carding, how it takes place. It will take place between the traversing flats, their point against traversing point of the cylinder. So this is very important operation that takes place here. In this particular diagram, we are seeing only one flat, and this is what the flat chain, it holds the single flat, and on this side this is the cross section, side cross section, and on the other side there also there will be the holding point. So on the bend it will be held there. So this is where the carding takes place. Elimination of short fiber, this will take place in case of the cylinder and flat zone. So optimum conditions are required here: right technical education, reliable functioning, precision in setting, technological right grinding, objective of reproducing distance measuring. Distance measuring plays vital role. In the conventional days, it was in terms of a leaf gauge it was used, and a distance, the distance was measured. Now we have sensors available in today's situation, so we can very easily monitor that particular distance. Now we'll go to the next. Elimination of short fibers, though it is not objective of this, but as I have stated here, 1 to 2% of the flat strip will comprise of these short fibers. Therefore, you can say 1% of the present short fibers are eliminated here, depending upon the conditions and type of fiber, the maturity level of the fiber, etc. There are so many points which are deciding this particular thing that to occur. Now, fiber blending. This will be happening, as I have earlier stated, residence time of the material on the machine. Of course, on the machine in the sense around the cylinder of the carding machine. No other thing will be responsible for this one. So, cylinder of the card is responsible for this. Normally, conventionally, we assess this thing that one fiber entering from Licarin will undergo around 20-25 revolutions around the cylinder, and then it will get an opportunity to go into the sliver. That will be doffed onto the doffer, and then it will go in the sliver. So here the intimacy of the mixing will be decided here, how long that fiber will prolong its journey on the cylinder of the carding machine. Fiber orientation. Now, fiber orientation, some diagram is available here. You can see this particular thing. This diagram indicates about the different orientation of the fibers which are prevailing on the cylinder, and then they will be delivered. So if longitudinal delivery takes place of the fiber, once it gets oriented here in between the cylinder and flat, and then it will have a better chance, because then it will deliver in that orientation form onto the doffer, and then it will go further. So that is very important aspect here. Now, sliver formation. Various mechanisms have been adopted, as I have earlier also mentioned. Now, the delivery side after the doffing, you can have a multiple rollers here, or you can have a single roller, then the collecting surface, the single roller, the brush, which will keep this roller clean, you can say, and then it will deliver into this mechanism. The crushing will take place. This can be a symmetric operation or asymmetric operation. A belt driven collection of this material will be there, and then it will go to the condensing device. Then further it will be condensed. In this diagram you can see asymmetric way of collecting this particular material. So this roller will collect the material. This will be transported in this strip, the belt, and then it will go further into the delivery side. So hank lies 4 to 5.5 say ticks, or you can say 3 to 6 kiloticks. That is in say for 0.12 to 0.22 in indirect system. 0.12 is the coarse sliver, and 0.22 that sliver which is going to be used for the fine count spinning. So something like this. So 3 to 6 kiloticks this sliver is normally produced. Kiloticks or grams per meter, one can say. So this is how the web formation takes place. Now, of course, auto-leveling system, very briefly we will highlight this thing and then we'll go further. Auto-leveling, actually, two types of auto-levelers are possibly used on the carding machine. One is the open loop, which is on the delivery side of the card, and closed loop in between the feeding device and the delivery side. So sensing you will do on the delivery side in one case, and regulate the speed of the feed, and you do the sensing on the feeding side itself, and you regulate the speed. So something like this. But as a matter of fact, we cannot go in a basic discussion on the auto leveling system in a great depth. That probably some different presentation will be required on that. So just quickly we'll go. Whatever impurities are there, I mean whatever irregularities are there, these irregularities, they get corrected with this auto leveling system. That is the purpose of that. So in between the delivery and feed, a closed loop will work, and on the delivery side, a open loop type of a system will work on the carding machine. So the whatever irregularities are either in the fed material, they are coming due to that the variation is coming in the delivered material, or the delivered material itself has some irregularities, they are required to be corrected. For that, the auto leveling was or is used rather in the modern cards. Now here we are going to see the passage. Now this is the very conventional passage I have say placed here, shown in this slide here, so that we easily understand the overview of the this entire system. As I have stated, though there are some very precise and minute changes, but overall the entire system has nearly remained the same. Of course, in today's situation, the lap feed system is not there. We are using the chute feed system. We have already seen that. So this first is the lap that was fed. Now the feed roller here, feed roller will feed in between the feed dish plate and the feed roller. You can see the serrated feed roller here. And then third one is the liquor or taker, and then it was responsible for beating below this liquor or taker. We were having moat knives, what were called as moat knives. One was inclined and other one was upright here. So this feeding zone was comprising of a lap produced from blow room, and then the feeding system, feed roller, liquor, beating up of the cotton flocks and removal of the trash, and the grid bars or the moat knives were present here. Trash was dropping at this point. So this is trash elimination zone, basically trash elimination zone and fiber further opening zone, we can say. The liquor zone is meant to do that job, and then it transfers the material. This is a very important thing. Now since the flocks have got the size, their size has been reduced, therefore what will happen, the transfer will take place. So here what we have seen in the carding action earlier, the point against another point, here point of this will act on, I mean the cylinder's point will act on the back of the point of the liquor. So the material will get transferred. So this is there are certain conditions of transfer of the material. Again, the direction of rotation, the vicinity, closeness or distance between these rollers, the points per square inch, number of wire points available per fiber, etc. So these are the conditions of transfer. We are not going to go in details of the conditions of transfer. You can refer Dr. R. Chattopadhyay sir's very excellent book on fundamentals of carding. It is a very excellent book explaining the carding process in detail. We are just seeing now the outline here. Now further the material get traversed on the cylinder. The direction is shown over here, and then in between the 6 number of flats, you can see the chain of flats what I was mentioning. To say for the understanding and for simplicity, say definitely I have taken this particular diagram. So the flat direction is shown like this and cylinder is traversing like this one. So large cylinder, 50-inch cylinder, it will rotate from front to back. Likewise, it will have its rotational direction. This will rotate, back to front. The cylinder will rotate from back to the front always, and these rollers will rotate from front to the back, Doffer as well as the Likere. So here interaction will take place as how just now we have seen the point against point, and then number of times the fibers will go around the cylinder. Number of times, 20, 25 times, depending upon they till they attain the segregated stage. They will go around the cylinder, and then finally, under certain conditions, a doffing arc is formed between the cylinder and doffer. Only in this place, whatever the space is available, only this much, though the cylinder is this much large, say this is 9 inches, for example, in the conventional card, this is 50 inches, this is 27 inches. So this circumference available here is so small, cylinder circumference and interacting doffer circumference is so small, doffing arc that is. Here only the transfer will take place. That fiber which has attained its segregated form will be now getting transferred onto the doffer. Now this will rotate like this, and here on the very conventional card we were having whatever called oscillating doffer comb. So this was doffing, this was oscillating like this one. It was giving a reciprocating motion. It was plucking literally the fibers arriving on doffer, and then it was delivering to the calendar rollers. And further, here another set of calendar rollers, small calendar rollers, coiling mechanism. This is the coiling mechanism where can is traversed, and here small coiler calendar rollers were there, number 10, and from there now this coiler will rotate and it will deposit the material, this sliver, in this can. So this is how entire operation works on the carding machine. So this is the first part related to the card. Now this video is becoming quite long, so I will stop here for, say, after discussing the passage of material up to this point we have discussed here, right from the beginning to this point, and rest about the carding we will see in the second part. So today I will sign off. Please do subscribe the channel, do share with your friends,